The solar energy sector is growing massively, but maintaining the panels efficiently continues to be a major challenge. Solar panels are exposed to environmental conditions every day, which can lead to issues such as dust accumulation, bird droppings, shading, cracks, glass damage, and delamination. If they are not detected and addressed early, the energy output reduces. A long-term study from Perth shows that dust buildup reduces power by 16 to 19% due to dust accumulation and by 71 to 84% due to delamination. Currently, many solar panel inspections rely on manual processes. Technicians may need to physically inspect panels or review large volumes of images to identify faults and maintenance issues. This approach is often time-consuming, labor-intensive, and expensive. Therefore, inspections are not performed frequently enough, and it is unclear where the problem lies. SolarVision addresses this by using drones to inspect solar panels faster, more scalable, and more efficiently. A drone captures videos or images of solar panels or farms. Our pipeline detects the solar panels, identifies the visible defects, and creates a heat map of the soiling. All results are presented in our interactive dashboard. SolarVision allows our customers to get cheaper, actionable inspections, showing exactly what problems occur and where, allowing them to react earlier, save time, and increase their energy output. This is how SolarVision works. A drone is flown over your solar panels or farms and makes an RGB video, in this case a Teo Edu. You can record and upload a video, or use the live video stream from the Teo to our web app to get results in real time. Control the drone with the Teo app, or directly from our web app. We can press Inspect Frame to detect what the drone sees right now. This takes a few seconds, even with YLO. This solar panel has some cracks. As you can see, our model detects them perfectly. Our system is able to detect 9 different classes. As the drone flies over the solar panel, it detects soiling and breakage. As we fly further, we find another panel. This one has discoloration in the middle and around the edges. When we inspect the solar panel, we see that our model does indeed detect multiple discolorations. The bounding boxes cover most of the discolored area. The model also predicts some microcracks, however. The probability is very low. This panel gets classified as critical. Our GUI allows us to choose between the Stage 2 models. We switch to YLOV26 and continue the inspection. The next panel is clean and has no defects. As you can see, our model does not predict any soiling or damage on the panel, which is correct. Under Results, you can see an overview of all classified panels. Next, we will explain our 3-stage pipeline and models, with its models in more detail, and show the key functionalities of our GUI. Thank you for considering using SolarVision.